Hi everybody, it's Mike Laurendeau from Karen Engineering. I'm the Eastern US and Canada Sales and OEM Manager for Karen. So I'm here today to present Defeating Machining Challenges, webinar number 4, with a focus on AutoComp. Let's address some machining challenges. First off, incorrectly measured part data. By relying on operators to measure parts correctly, there can be a lot of issues with in-process or post-process gauging. AutoComp can grab all that data, compile it, and compensate the machine. Number 2, tool measurement data entry errors. This plagues every shop. They say statistically 1 in every 300 keystrokes is an error. I think if you type like me, it's probably more like 1 in every 10. But AutoComp can prevent that fat fingering from occurring. Number 3, a miscalculation of offsets. By relying on math or an antiquated macro to populate data is flawed thinking. We can remove the operator from this part of the equation and get you better part quality, but also reduce scrap. I've spoken over the last few weeks in this series about the current situation with COVID-19. There is a theory that reshoring of manufacturing was going to happen in the United States. That's no longer a theory. It's become our reality, and it's exciting. The lowest entry point cost-wise to satisfy orders for our customers is to optimize their current equipment. It's already sitting on their floor. In addition to that, they've laid off employees. Backfilling those positions is going to take our labor force and exacerbate the situation and make it an even lower skilled labor force. Do you really want your operators to possibly crash a machine or make bad parts? So what I want to do is introduce to you the solution to these issues, and that's AutoComp. So AutoComp is an automatic toolware comp software. It's a Windows application that communicates directly to your CNC. It accepts the measurement data from almost any type of electronic gauge. It's also important to state that a lot of times, we're an engineering firm. We wrote this software. So if a specific gauge that you have doesn't have the ability to export a CSV file, we can, in some instances, write a custom app in order to pre-process. AutoComp eliminates the human error by automatically adjusting offsets. So how does it work? Quite simply, the part's machined. It then goes to a gauge or a series of gauges. AutoComp then takes all that data and determines if a compensation is required. And finally, the offsets are automatically adjusted. So here's your nice, tidy closed loop. AutoComp can accept, like I said before, most measuring devices, electronic measuring devices. It's important also to note that we have a probe in this presentation. You can actually extract the data from a probe and then do something with it. You could trend, for example, multiple dimensions and then comp, or just extracting that probe data can be incredibly useful for most customers. So Gauge produces raw data files that are row and column format. And what AutoComp is doing is watching a specific folder for that data to appear. So you as the customer or user of AutoComp creates a routine consisting of your critical features. And then you apply tolerances and compensation limits for each dimension. AutoComp will then essentially memorize the routine and will be a fully accessible file for part changeover. We'll go over that in our live demonstration. Most of our products are typically set up to be a single screen or make it incredibly easy to maneuver through and set up. Here is an example of how you would input a dimension and its characteristics. So this is how AutoComp automatically does what the operator would normally do. So you got to identify the name, your nominal is input here, as well as your reject limits. Like I said, we relate that to a row. And then on this tab, we have setting up your compensation parameters. And there's other features that are really cool. Being able to establish a tool wear limits. You give us the max amount of compensation for that particular insert, we put that number in there, and then we can collect an aggregate of that and actually give you a tool life indicator. Also, CNC complement. This is something that almost every one of our customers use. What this does is it prevents an erroneous measurement from getting into the CNC control. Under the control compensation parameters, this is where you relate the data to either a variable or a tool offset. So here's an example of our runtime display. You've got your current part data in the active column and previous part data. Here are your tolerance limits and your compensation limits. When the data points come in, green is good, yellow means a comp was sent to the machine tool, and red, it means the dimension is out of tolerance. And here is that tool life indicator that I was telling you about. That will go from green to yellow to red. This is an easy indicator for the operator to be able to see at a glance how their tool is doing geometric. We also have a part view, which I'm going to show you in our live demonstration as well. Part view allows you to put a print or a picture up there so the operator can easily see a location and status of whether that dimension was taken. So trending or not trending. For each dimension, you can use tolerance limits, comp limits, and trending to calculate tool comp. In a standard measurement, when trend is not used, the comp limit will cause a tool offset on that particular measurement. With trending, we take a running average of dimensions. This is a lot of times can tighten up your CPK. So if you have a really stable process, but you might not necessarily want to comp every single time. Trending can help avoid these unnecessary comps, but also tool changes. We have macro variable programming capabilities. Because we are integrated into the CNC, we can alert whether the cycle or measurement cycle is complete, a good part, bad part, tool is at end of life, we can stop that process. And also, if you have a gauge requirement, measure every 5 parts, every 50 parts, we can stop the process and alert your operator to take a dimension. I also like to note that AutoComp is MT Connect compliant. So now just give me a minute here. I got to get out in front of the live demonstration and get going. Hey everybody, for today's live demonstration of AutoComp, we actually have 3 different gauges all interface seamlessly to the CNC behind us. The first thing I'm going to do is I'm going to hit play to get the CMM to start its measurement cycle. This isn't a normal CMM, it's actually a ZCAT that's designed to be a tabletop style. So the ZCAT is going to run through its measurement cycle, it's going to collect all of these data points and then assign them in a row and column format. Now this is important because AutoComp in the background is watching a Windows folder where those gauge dimensions are going to be deposited into that folder. It's also important to note that AutoComp knows the range of these dimensions, so it can automatically pull up the correct part routine based on the dimension. So part changeover is a snap. So the ZCAT has just finished its measurement cycle. Now what you're going to see is it automatically pull up the AutoComp screen. I want to pause for a moment and walk you through a couple of the features here. First of all, the interface is completely interactive. So here you can see this horizontal green line is our nominal. The yellow lines around that are our compensation parameters, and then reject limits based around that as well. A green is representative of a good dimension, obviously. A yellow means a compensation was sent to the CNC control. And if there was a red dimension, which you'll see in other gauges further on down the presentation, those are an indicator of a rejected dimension. These are all user-defined limits. I also want to show you this dialog box here. Now this is actually representative of tool life. So you tell us the usable life of that insert or that tool, and then we keep track of every time we compensate that and give you a runtime display of how that tool is actually doing. We also can tie that back to a macro variable as well, and stop the process if that's how far you want to go. Now the next gauge that I want to show you is a vernier caliper. Now this particular vernier has a Bluetooth device embedded in it. So this caliper is communicating via Bluetooth to the PC where AutoComp is housed. Now this is the same part we were measuring on the CMM. We're going to measure 3 dimensions. We're going to measure hex diameter, the height of this particular hex, and the boss diameter.
So what I'll do here, and what I really want to illustrate, if you look at the CNC control behind us, is hopefully I can send a compensation to that wear offset. So I'm going to click that one there. So that first dimension, we automatically pulled it up, and you can see the compensation. I'm going to take the additional dimensions here, this height and the boss diameter. And as you can see in the runtime display, we've just populated our 14th part. And subsequently, every one of those, a compensation was sent to the control. Now, while I'm here, I want to show you a couple more features. We have different views that you can use. So this is our chart view. We also can pull up a part view. So in the part view, we have the ability to interact with an image or a print of the particular part. So as I'm going through this, I can simply take a dimension, and you can see which dimension was just taken. So we're going to fill in each one of these flags. Now this is important for scenarios where maybe you got interrupted in mid-measurement, or maybe you have a complicated part and you just got lost. So now I can refer to this and say, oh, I got to measure this particular part of the feature and this particular part of the boss. Okay, the third gauge that I want to show you here today is a 2D laser micrometer. This one's made by Keyence. Now these are really great for scenarios where you have a robot placing a concentric part onto the stand and presenting the part. So as you can see this display here, all we're really going to do is instantaneously the CNC is going to say, Mr. Gauge, please measure the part. The gauge is going to measure the part. You can see it here. It's going to automatically pull up the correct part routine for this particular part. We just measured part number 25. We've got some compensations that were sent to the CNC as well. So that concludes the live demonstration of AutoComp for you here today using these three different gauges. But just to reiterate, AutoComp is really designed to be a gauge talker. It's designed to make all these different gauges work instantaneously and easily to a CNC control and remove the operator error. These can be used in conjunction with each other or just one individually at a time. I'm going to hop back into our presentation now.
I want to summarize what you've learned here today with this AutoComp presentation. AutoComp is going to eliminate the data entry errors that are prone in our industry. We can track offsets, trend. We can determine comp on multiple path or complex machines. We are statistically controlling offsets and are able to maintain better part tolerances. We also are compiling an enormous amount of historical tool wear data, and all that can be exported to an SPC type software. And finally, when you learn AutoComp, now you have the same type of interface for any gauge and any control. So you only have to learn it once. Also, are you looking to implement a robot? I mean, I see more and more of them out there in the world today. Are you gonna stop the machining process, letting an operator go in there, comp your machine tools at the control? AutoComp really just completely eliminates that need and stop the process. So it's a nice clean fit for robotic integration. So I want to summarize the whole Defeating Machining Challenges webinar series by reintroducing and quickly covering our intelligent solutions. We introduced a product called Tool Connect, which automates the off-machine tool measurement process. So it's the link between your presetter and your machine tool. It's going to significantly reduce setup and cycle times by virtue of having a presetter. It's going to eliminate all the scenarios where an operator is going to key in the wrong geometry into the control or put the tool in the improper pot, that sort of thing. It's going to automate and confirm your complete workflow of loading the tools and unloading the tools. So once again, and it's something that's very constant at Cairn Engineering, is our ability to create an interface for any type of machine so your operators can load and unload tooling or interface gauges to any type. And finally, integrating the tool management side of things and eliminating the post-processor. So during cutting, we introduced TMAC. So TMAC detects tool wear and optimizes your cutting to maximize your tool life. We can make automatic real-time adjustments to adjust your variations in your cutting conditions, your tooling, your material, that sort of thing. We're going to automate the process and allow you to finally go unattended with confidence. We do this using a direct interface of our product to the CNC control. And finally, you all want data. We have been able to provide advanced analysis capabilities to actually review your cutting data as well as the health of the machine. We do this all by utilizing our high resolution sensor data. We covered it today. After cutting, we introduced AutoComp to you. AutoComp is going to eliminate the human element of creating error in the process. We're going to calculate the proper compensation automatically, so remove the math. We're going to give you accurate reporting of offsets for your further analysis post-process. And finally, it's going to allow implementation of a robot-loaded machine. It would normally require some sort of automated offset control. I wanted to quickly, while I have a few moments, introduce another one of our flagship products. It's called Detect It. Detect It communicates with custom Caron Engineering USB sensors to analyze machine irregularities and also make those corrective actions. We're constantly discovering with this product new applications for this, and it's based on the enormous amount of sensor options that are available combined with the multiple analysis modes. So questions or comments, please email marketing@caroneng.com. Once again, marketing@caroneng.com. I want to thank you again, and I hope you all have a productive rest of the week and an awesome weekend.